Hi, grade 6. This is day 33, page 436, numbers 5 through 37. Please spend some time on page 434 and 435. I'd like you to pause this video and read those pages. Pay special attention to the definitions of the different types of quadrilaterals that are on page 434. The definition for a quadrilateral, the definition for a square, the definition for a trapezoid or a parallelogram. Please pay special attention to those because those are important for solving the problems today. Okay, go ahead and pause. Okay, I got a bunch of shapes behind me and we're going to take a look at them. And we're going to compare them to that chart on 434 that's showing all the different shapes. And what you should realize, folks, is that very often one particular shape can have a number of different names, but only one of the names is the most specific and the most accurate. So let's start off first with this puppy right over here. And let's look at page 434. Could this shape be called a quadrilateral? Well, the definition for a quadrilateral is that it is a shape that has four sides. Does this have four sides? Yep. So technically, we could call this a quadrilateral. I'm going to abbreviate it with a Q for quadrilateral. Could this shape be called a trapezoid? The definition of a trapezoid is a quadrilateral that has one set of parallel sides. This doesn't have one set, this has two sets. So it's not a trapezoid. How about a parallelogram? Parallelogram's definition has opposite sides parallel and opposite sides congruent, and that's what we've got here. We've got opposite sides parallel, we've got opposite sides congruent. We could put cute little arrow here, cute little arrow here that tells us that this and this are parallel. We could do the same thing over here. We could put a couple of these cute little arrowheads here and here because the opposite sides are parallel and the opposite sides are equal. So we could call this a parallelogram. Could we call this a rectangle? Is that a rectangle? The definition for a rectangle is a parallelogram with four right angles, and we've got that. It is a rectangle. How about a rhombus? Is it a parallelogram with four congruent sides? Yeah, this is also a rhombus. Finally, is it a square? Our definition for a square is a parallelogram with four right angles and four equal sides. So it's a square as well. This particular shape is 5 different names, but which one of them is the most specific? The one that really gives the flavor of what this object fully is? The answer is square, of course. This is a square. You've been calling this a square since kindergarten. Okay, let's move on to the next shape right here. What kind of names could we call this one? Is it four-sided object? Yes, so it's a quadrilateral. Is it a trapezoid? Does it have one set of parallel sides? Nope. Is it a parallelogram? Does it have opposite sides equal and opposite sides parallel? Yeah, this is a parallelogram. Opposite sides are equal. Opposite sides are equal. Additionally, opposite sides are parallel. Opposite sides are parallel. Is this a rectangle? No, it doesn't have right angles. Is this a square? No, it doesn't have all equal sides and right angles. Is this a rhombus? No, rhombuses have 4 equal sides. Okay, so which one of these is the most descriptive or the most complete in nature? And hopefully you recognize that this is a parallelogram. That's its best name in this particular case. Let's look at this one. What names on page 434 could apply to this one? Well, it's definitely a quadrilateral. Is it a trapezoid? Is this side parallel to this side? I don't think so because we don't have a right angle over here. This line goes in so that the angle here is probably 85 or 86 or something like that. So I don't think this is a trapezoid. It's certainly not a parallelogram like this one. It's not a rectangle, it's not a rhombus, it's not a square. So the best name for this one is a quadrilateral. How about this one right here? Those two arrow thingies tell you that those two sides are parallel to each other. Notice we have just one set of parallel sides. Is this a quadrilateral? Yep. Is it a trapezoid? Yep. Is it a is it a parallelogram like this one over here? No. Is it a square, a rhombus, a rectangle? No. Which one of these is the best choice? In this case, it would be a trapezoid because we have a four-sided object with one set of parallel sides, which is the definition of a trapezoid. How about this next one right here? The two lines here and the two lines here indicate that they're equal in length. The 1 and the 1 tick mark indicate that this is equal in length to this one. We've got four right angles. I could call this a trapezoid. I'm sorry, a quadrilateral. I'm not going to call it a trapezoid. That's not a trapezoid. It is a parallelogram, though. It's not a rhombus, but it is a rectangle because it fits the definition of a rectangle. Which one of these is the most specific? Oh, that would be a rectangle. How about this one down here? It's a four-sided object, so that makes it a quadrilateral. It has opposite sides parallel to each other, parallelogram. It's not a rectangle, it's not a square, but it is a rhombus because it's got four equal sides. Which one's the most specific? Rhombus. So hopefully that helps you with one part of this assignment. You look at the shape, you compare it to those definitions on 434, and you name the object with the name that is the most specific in its definition. Okay, let's look over here at one other part of the assignment for today. Remember when we said that in the case of a triangle, every triangle, if you add up the three angles, we know that the three angles have to equal 180 degrees when you add up the measures of their angles? Well, there's a rule for four-sided objects as well. Four-sided objects, the four angles, when you add them up, have to equal not 180, but 360 degrees. So let's take a look at this first problem right here. I've got a 65-degree angle, a 115-degree angle, and a 70-degree angle, and an angle that's called x. If I want to figure out the measure of x, how do we do this? Not difficult. We take 65 plus 115 plus 70 plus x, and we make that equal to 360 degrees. This plus this is 180. Plus 70 is 250. To get x by itself, we're going to have to subtract 250 from both sides of the equation. And if we do that, x has to be, in this case, 110 degrees. So our x angle right here has to be 110. Let's try it again with this problem right here. 77, 99, 109, and x degrees. We're going to add up all of the measures of the angles and make them equal to 360 degrees. These two added together make, let's see, 16 carry the 1, 176. These two added together, what's that going to be? 285, it looks like. 5, carry a 1, yep, 285. To find x, we're going to have to subtract 285 from both sides of the equation. Don't know what that is. I get 75 degrees. Our x value in this case needs to be 75 degrees. Let's try it with this one. We've got 90 degrees, 52, and x. 90 plus 90 plus 52 plus x equals 360. This is 180. These two added together make 232. And to get x by itself, we're going to have to subtract 232 from both sides of the equation. And when we do that, we get 8, we get 2, I get 128 degrees. So x right here would have to be 128 degrees. Okay. Hope this helps you to think through how you're going to solve these problems today. If you have any questions, though, please give me a call. My phone number, 517-242-3138. You're probably hearing that in your sleep. Anyway, have a good day. Bye.